G'day, it's Rob here again. I've had a few comments recently about the type of lathe stand that I use for my two little lathes, and basically I thought I'd do a video and just show exactly how this type of design works. This is different to a conventional lathe stand in that the lathe sits on a big spanning beam. This type of design, we've got the lathe bolted directly onto a beam the width of the foot plates of the lathe, or slightly larger even, and then suspended on the ends, welded onto or bolted onto legs at each end, is called a spanning beam type lathe stand. Depending on how rigid and massive that beam is, if it's really rigid and really massive, it then becomes a torsional beam stand, because basically that beam will not flex to any degree, and any movement through any compensation for movement or unevenness is taken up in the legs, which are made of a more flexible material. So this is the design I use. This is a torsional beam is actually a design that they use in ships, in engineering rooms in ships, to keep lathes aligned correctly. They actually have them gimbaled on the ends, on one end, and then they have a leg that normally comes down and is gimbaled as well, so that ships are like aeroplanes, you know. I mean, if you've ever set up the end of an aeroplane in really bad weather and looked along the plane, you can see the whole thing flex, you know. It's pretty amazing. And ships are exactly the same, where the ship is continually moving, the hull is continually flexing, and that's why they use this type of setup, torsional beam. And okay, you know, my shed floor is not going to be moving or flexing. Why would you bother to use a torsional beam or a spanning beam? Well, the main thing is that they're easy to make, very simple to make. Anybody with a stick welder can easily knock out one of these. They're cheap to make. And also, when you weld them up, you haven't got all those problems of distortion that you get with a normal flat top bench stand, lathe stand or lathe bench. So you get around those distortional problems quite well. Also, you can put a tray, a slide-in-out tray underneath the beam, whereas if you're bolting down the lathe through the tray where you can't pull the tray out, and if you bolt it down onto the top and then put a tray under, you're only going to put it under sort of here and here sections, so oil's going to be pissing everywhere except in the tray. And the other big advantage is that by doing it this way, you get a lot more clearance for your controls. Now, if this was bolted onto a conventional lathe, the tray would be there, and that hand wheel was right down onto the tray. Doing it this way, you've got massive clearance. You keep out of all the crap. You've got plenty of room for all the crap and rubbish to fall down. It's just 1,000,000% better, in my opinion. So I did this one first. This was the stand I did for the old CQ9325, and then I turned my attention to my old Shorblin, and I'll show you the Shorblin one. Okay, well, here's the Shorblin, and it's exactly the same sort of setup, but instead of using angle iron, which, as I did in the original one, I used U-section, which is it's better. You've got less chance of any wobble. You don't need, there's not much need for diagonal bracing. On the old one over there, I had to use a piece of diagonal bracing across the back because it was getting a bit of flex this way. But by using U-section, you can hide all the welds, weld it on the inside and do parallel welding. So it's not just welded sort of vertical, horizontal. You just go two horizontals and forget about the verticals, and it'll brace it up quite nicely. Also, one thing, if you ever go this way, now you can see how the tray just slides in and out on this one. This isn't the right size tray. It wants a bigger tray, but this is just for now. But when you weld these up, I've seen someone else make one of these, and they welded it up so that the spanning beam was level with the top of the support. Now I deliberately didn't do it that way, because if you do that, if you put that top section there level with the end sections, you're then allowing any oil to run that might, I mean, you're going to have oil if you're going to use a lathe. You're going to have oil, cutting fluid. It's going to hit that beam and it's going to run across, and it can run off the ends at each end. By dropping it down 1/2 inch inside of your end beams, then welding it, the oil can flow across, it hits that upright section, and it's unlikely to capillary rate up, and it can only run down. So basically your beam is not as wide as the width of the tray and the shelf underneath. So I think that's something you want to consider if you do it. Keep that beam down slightly, otherwise you could have oil problems. Now, making these lathes up, I used big, heavy section of 6mm thick RHS box section. Got it from this is all scrap salvage. The whole bench cost me like $30. And I mean, to get a piece the width of your lathe is the challenging part. You can do it, but of course the bigger the lathe, the bigger the problem. These are only relatively small lathes. So if you've got a lathe with a wider footprint than this is, the only way around really is to get two slightly smaller sections, and then just stitch weld them along and have two making up one beam. Now, being a torsional beam, this beam could be made out of cement if you wanted to be adventurous. You could actually make up a beam out of reinforced concrete. You could float the top off, have it dead perfect, and you could have bolts on the ends of the cement to bolt it into end plates on a lathe stand. There's all sorts of things you could do. So you can use one big hunk of RHS, you can use two stitched together. You could even have two slightly apart. I mean, I wouldn't want to do that myself, but it's possible. Or you could use concrete, cement, and you could float it off and you get it at dead level. So there it is, just a little bit of info on this. I like the first one so good I made a second one. But when I did it this time, the second one, I welded the beam onto angle iron plates at each end, and they then bolt onto the frame. I did it that way so that when you're welding it up, it's not so heavy to try and move around. I mean, it gets pretty damn heavy. This is not lightweight, this stuff here. And by doing it this way, you can move the whole thing, take the lathe off, take the beam out, unbolt the stand from the floor, and you're ready to go. So I'll give you a look around the back as well. Right, in the case of the Shorblen, we've also got another piece of RHS which is being trimmed, which has got a plate welded into the end of it, and that bolts the outrigger for the motor and everything against the side of the main beam. So once again, it's all rigid through here, but the legs, the supports are free to flex to some small degree, enough to do the job. On the original design, the original one I did for the LCQ9325, you can see I had to put a diagonal piece of angle iron across the back to give it bracing, because there was a little bit of side to side on that. Angle iron is nowhere near as rigid. It's a lot more flexible than U-section. So yeah, definitely get yourself some racking steel or something like that. Doesn't have to be terribly heavy. I think that stuff I used was 3 mil, and weld it up and away you go. But if you do put a diagonal brace in, well, of course that would be the last thing you would put in. You would bolt the legs down. I just bolt them diagonally on two corners. Once it's bolted down, you then put your diagonal brace in. That way any distortion that did occur in the stand base will have taken place, and it'll all bolt up good and rigid. So you can see I just got angle line coming through here, a board on that, and then freestanding shelving sitting there. I mean, if you're going to make it properly, I mean, I just do these jobs as long as they're functional, I don't really care if they look like $1 million or not, as long as they work. I've seen people spend hundreds of dollars making up really nice benches with nice metal drawers that have rollers and slide in and out. Great, good on them. That's fine if that rocks your boat. I don't really give a stuff about that. As long as it works. I like wooden drawers, even though they haven't got rollers, they slide all right. I like wood because it doesn't get condensation in it, you don't get rattles, it absorbs the oil. Just personal taste. But certainly you could rig it up and make a really professional job out of it. But I'm not that sort of guy. Okay, so what's the correct height to make a lathe stand? Well, that will vary with the person. I'm nearly 6'2". Other people shorter than me will need a lower stand. But the golden rule, as I was taught, is that the stand is at the correct height when, if you use the lathe, when you use the cross slide, your elbow is pretty much in line with the axis of the cross slide handle, because that is the natural position you'll be holding your elbow at 90 degrees. So basically you use that as your reference point. That is the point, the height at which you should be working towards, and you basically would use that measurement to the floor, take away the distance from here to the base plate of the lathe, and that basically will be the remaining amount will be the height that the base for the lathe will be sitting from the floor, if you get what I mean. So that's it. That's the way you do it. So there you have the stands that I made. Everybody's got their own idea on lathe stands, and this is just mine. The first one worked so well that I made the second one, and I personally think that they are superior to a conventional stand for several reasons, as I pointed out. As you can see, the second one I put additional cross bracing where the tray is, whereas on the first one, if I go back to the first one, it's only got one cross bearer, a shelf, which is basically down here, and the tray is sitting on some shelving that sits on that. So it would be better, it would have been better if I'd done it like the Shawblin one, where I put cross bracing here as well as down there. It just would have made it a little bit better as far as side to side, and I had to put a diagonal brace in, as I showed you. But basically you learn as you go along, and yeah, it works good. But the second one I think is a bit better design wise. So there you go, get yourself a stick welder. You can buy them off Gumtree for like, $40, and get cracking. All right, that's it. See you next time. Cheers.